an overview of Apache Kafka use cases, and I'll show you like a demonstration, like a demo of Apache Kafka. Okay, first things first, what are distributed systems? Does anyone know what distributed systems are? Okay, distributed systems in its most simplest definition is a group of computers working together as to appear as a single computer to the end user. These machines have a shared state, operate concurrently, and can fail independently without affecting the whole system's uptime. Okay, distributed systems are kind of like, let's say this was like a mainframe. You have your own system, he has his own system, he has his own system, yeah. So that's like an overview of what distributed systems are. You guys are sharing the same resources together. Basically, that's what distributed systems are. If you look at this picture, you can see like on the left, there's a guy pulling a plane, and on the right, there are like multiple guys pulling a plane. I'm kind of going to use like an analogy of this to explain what distributed systems are. Now, on the left, we have like close to like 10 guys pulling that plane. That plane represents like load or data load, and which from the picture you can see the guys on the right can achieve the goal of moving the plane forward rather than the guy on the left. So basically, that's the main importance of distributed systems. If you put multiple systems together and they work together to work on a data load, and I guess distributed systems makes it more easier to work on data processing and stuff like that. Now, what are messaging systems? Messaging systems are responsible for transferring data from one application to another, so the application can focus on data without getting bogged down on data transmission and sharing. In other words, messaging in data computing is a technique that enables high-speed asynchronous program-to-program communication with reliable transmission. Now, in a distributed system, for instance, in this picture here, this is like an image of like a distributed system. The link between like the first system is kind of like that's like the messaging system. That's how like the two systems communicate with each other. The first picture, you can see like there are two systems linked together. That link is the messaging system itself. And for each link, for like two systems, you can have one communication. For four systems, you can have like 6 communications. That's 6 messaging system links working together. Now, since I've talked about distributed systems and messaging systems, what are distributed messaging systems altogether? Distributed messaging is based on the concept of reliable message queuing. Messages are queued asynchronously between client applications and messaging systems. A distributed messaging system provides the benefits of reliability, scalability, and persistence. Now, when you're talking about distributed system, you have to talk about scalability, and there are 2 types of scalability. There's horizontal scalability and there's vertical scalability. For horizontal scalability, okay, now let me use my system for example. Let's say I want to process like 120 terabytes of data. Now, how do I make my system more faster? How can I optimize my system to work on that data? I can either choose horizontal. I can either scale my system horizontally or vertically. When I'm scaling my system horizontally, what I'm doing is I'm adding more resources to the system. That's what horizontal scalability means. For vertical scalability, it means I'm including other systems rather than resources to the system. Okay, horizontal scalability can be like improving the RAM of my system. That's like a form of horizontal scalability. Vertical scalability means like I can add this guy's system, I can include this guy's system, any one system, like 5 or 6 more systems to work on that particular data set. Now, there are examples of distributed messaging systems. We have RabbitMQ, we have Apache Active MQ, we have Zero MQ, and we have Apache Kafka. During this case, I'll be talking more on Apache Kafka. Okay, an overview of Apache Kafka. Kafka is a distributed streaming platform that is used for publicly subscribed to streams of code. Kafka is used for fault-tolerant storage. When you're talking about fault-tolerant storage, it means that, okay, let's say I was working on my system, I included this 3 guys system. Fault tolerance in the sense that if data is missing from this system, there are like backups on this other guy's system. So that's what basically fault tolerance means. And Kafka replicates topic log partitions to multiple servers. Kafka is designed to allow your apps to process records as they occur. Kafka can be used for data streaming and big data processing. And one of the main importance of Kafka is that it's fast and it uses input and output efficiently by batching and compressing records together. Kafka is used for decoupling data streams. Like I said, Kafka can use data streams. You can use Kafka to work on a large data set. I'm talking from a data science perspective now. You can use Kafka to work on a large data set, and you can use Kafka to stream that particular data set into the system you want to use for a machine learning model. Kafka can be used to stream data into data lakes, applications, and real-time system and analytics system. Now, the history of Apache Kafka. Apache Kafka was made by LinkedIn. LinkedIn was the first company to develop Kafka using the Java and Scala languages. Its source code was open source in 2011, and it became a top project of the Apache Software Foundation in 2012. In 2014, several founders of Kafka set up a new company named Confluence, which specialized in Kafka. Now, before Kafka was born, it was an open source project, but right now it's owned by Confluence. It's like a company that it's like a commercial product. It's not more an open source project anymore. The purpose of the Kafka project is to provide a unified, high throughput and low delay system platform for real-time data processing. Kafka delivers the following three functions: publishing and subscription, processing, and storage. Now, I'll talk about the terminologies used in Apache Kafka. When you're working with Apache Kafka, you hear terms like records, topics, producer, consumer, sets, browsers, zookeepers. Basically, when you're talking about topics, let me start off with the producers. Okay, in a distributed messaging system, we have both the producers and the consumers. The producers, they are into more. Their main role is providing a venue for ingesting data for the consumer to work on. So basically, producers create a record and publishes it to the broker, while the consumers consumes records from the broker. Now, when you are creating an Apache, a Kafka project, you have to make a topic, and that topic, producer writes a record on a topic, and the consumer listens to it. A topic can have many partitions, but must have at least one partition. Now, let's discuss about the use case of Apache Kafka. Apache Kafka can be used for stream processing. It can be used for website activity tracking. I can remember there's one particular KD that we had, and we talked on web analytics and tracking visitors on your website. So you can use Apache Kafka for that too. You can use Apache Kafka for metrics collection and monitoring. You can use Apache Kafka for log aggregation. Now, when you're working in a cloud development environment, your server, day to day, your server produces something called logs. That's like the events that happened that day. So you can use Apache Kafka to store your logs. You can use Apache Kafka for real-time analytics. Okay, currently the project I'm working on for Bincom right now is Twitter data analytics. So I could use Apache Kafka to stream tweets and store it. Rather than storing it into a database, I can store it into Kafka. And I can use Apache Kafka to ingest data into Apache Spark or Apache Hadoop. Apache Spark and Apache Hadoop are used for big data processing and big data storage. And when you're talking about Hadoop, Hadoop is divided into two parts. We have the HDFS, and that's the Hadoop distributed file system that stores the data you get from Kafka. And we have Apache Spark too, and it does the same stuff exactly. Now, there are some organizations that utilize Kafka. For instance, Airbnb, Cloudflare, Twitter, Uber, Tumblr, Netflix, PayPal, Yahoo, Pinterest, and Spotify. I heard of Netflix. You know, when you are watching on Netflix, you get like recommendations of what to watch, movie you watch. So in real time. Apache Kafka stores what you get, like your inputs. It stores into a data set, and Apache Kafka stores your recommendations in real time to his own to his own file system. And I know Twitter makes use of Apache Kafka for Twitter for tweet streaming, for data streaming, and Spotify makes use of Apache Kafka too. Okay, right now I'm going to do like a demo of Apache Kafka. I'm using Apache Kafka to make a relay. I'm going to use my Apache Kafka for relay messages. So the first things first, we have to download Apache Kafka. You have to download the Kafka project from the website. That's from Apache project. So once you download it, Okay, now, first things first, what you need to do is where you downloaded your Apache Kafka file from, you go to the directory where it's stored. And I downloaded my Okay, now I cd to my Kafka directory, and the first thing I have to do is I have to activate Zookeeper. Zookeeper is like a broker. With Zookeeper you can activate your Kafka project. So first thing I do is I go over to my directory and I input in this command, Windows start my Kafka server, config, I need to add my Kafka to my path. Okay, I go to my environment variables. Okay, the new variable. No. Sorry, yeah. Okay. Now I add my path. unplugged in the morning. I don't know what's going on. Oh, sorry. Sorry. Okay, yeah. Oh. I'm trying to extend my distance to show the projector.
You want to extend or you want
I want to extend, yeah. Huh?
What's the problem?
I don't know. I'm trying.
You don't extend.
Yeah. So. Yeah. Okay. Okay. I've started mine. Okay. The first thing I did, I started my Zookeeper. This is broker. I started the broker server itself. So the next thing I have to do is I need to start up my Kafka server. So what I do is I come here, cd out, cd to my Kafka, namespace. Then I write this.